Uh, I mentioned previously that um, pointer is not simply pointer. It got a data type to point to. So you can define an integer pointer like this. So pi is an integer point. You can define a double pointer. What's wrong with this? You can define a double pointer, PD, like this. You can define a character pointer. What's wrong with this guy? Okay. It's too slow. Faster. Character pointer. Strange, what's happened? Character pointer. Okay, PC. Okay. So it's a pointer to character. Okay. You can also define a flow pointer. Strange. What happened? What happened? Flow pointer. Okay. So, in fact, OPI, PD, PF, PC, they occupies PI, PF, PD, PC. They are all variable. Okay, they are all pointer. The difference is that this is a space can save address, and the size is 8 bytes. And this PF is float star. And how big is it? 8 byte. Okay, and this is the location large enough for 8 byte, large enough to say an address in the memory space. So the same here. This is a double pointer. It's an address, and they all are 8 bytes. And this is character. Okay, and the size is 8 bytes. Okay, they all are the same. Okay, they are address. Okay. Now, I say C is a strong type checking language. So it will check this address supposed to point to an integer. And this address supposed to point to a data available float. This space, this is address. This address supposed to point to a double variable. And this address supposed to point to char. Okay? So this is a pointer data type. Okay? Now, in C, we have a special pointer. The purpose Okay, the purpose of this kind of pointer is just to save an address. The size is the same as 8 bytes. And in C, we use in void star. Okay? And I just call it VP. So we can define a pointer to no data type. Okay? This is a pointer to integer. This is a pointer to float. This is a pointer to double. This pointer to character. And PV is a pointer to nothing, a void. Okay? So how we define pointer to nothing? Just using reserve void star PV. Okay? But the same. All this have one thing in common is they all are available. They all can say save address. Okay, they all can say address. So let's continue this example. Okay, supposedly we take the address of variable I and say in PI, and we define a void pointer called VP. PV, okay. PV is a pointer point to no data type. Okay. The purpose is just to say address. Okay. So can we do this? PV is equal to PI. Can we do this thing? The answer is yes, because PI say an address, and we take the PI's value, which is an address, and then equal sign assigned to PV. And PV is also a pointer. It's just a point to nothing's pointer. So PV can save an address. The only problem here is that the data type of PI and the data type of PV is different. One is a pointer to integer. One is a pointer to nothing, to void. So if you do this, the only problem is type. So what you can do is, if we compile this thing, you will see a warning, which is warning these two data type is not consistent. Okay. Okay, this PV, this is PI. Okay, one is a pointer to void, one is pointer to integer, but they are all contain address. So all we can do is to use casting. We convert PI into void star. Okay, we do cast. Okay, this is called cast. Cast. It change the data type. Okay, we change the integer pointer into void pointer, and then say to PV. Okay, now we take the PV and we do cast again, integer star. Whoops. Integer star. We do cast. Okay, star. We change the data type of PV from void star to integer star. So you can safely save to PJ because PJ is an integer star. Okay? And then we are fine now for the rest of the stuff. Okay? Maybe we do another thing, is we change the value of PV. Can we change the value of PV or star PV? The answer is yes. Okay? We set PV and we cast INT star. We change into 30. Okay? Now we do this, okay? And we print the address of PV. Okay? So PV is equal to %X. And here the same. We do the same thing is we also print PV is equal to %X. Okay? PV a pointer, PV %X. Okay, and destination. Okay, now here the same. PV is equal to %X. Okay, and here we print okay, PX. Okay. PX. No, PV. Okay. Here, PV. Okay. Now, so we rebuild and run it. So we can see now we got PV, and PV is the address. Okay, and then these addresses are all identical. And this address is I variable's address. Okay, the address of variable I. Okay, and we change the PV value, the location pointed by PV. We into 30. In fact, we change everything. Okay, all these things are changed. So PV is equal to %X. We print PV's value. Okay. PV's value is also address. So we introduce a pure point that point to nothing. It's a pointer without data type. Okay, not like a pointer to integer, point to double, point to float, point to character. Okay. Now let me say this example. Okay, now here come now I want to let you guys know a little bit about Visual Studio, about the compiler. In fact, in Visual Studio, we have two compilers to compile C program or to compile C++ program. One is called release. One is called debug. In Visual Studio, we have two C compilers, and their focus are different. These two versions of compiler, release and debug, their focus are different. Okay, release are focused on efficient. So the compiler will compile into a machine code. They can run more faster, say more memory space. Okay, the focus, the concern is efficiently use the resource and save the memory space. Take less CPU time to complete the program. This is release version. And another version is called debug. Okay? The debug version is a very good compiler. When the time I start writing C program, I don't have very good debugger to use. Okay? And what the debugger do is to generate more extra memory space to effectively help programmer to debug the program. Put it in a simple way is you can stop the execution of program at any location of your program you like. What's the purpose you want to stop a program? Is let the programmer to check the value available is what you want. The variable of the value available is correct or not. So you can trace, okay, trace. You can trace in your program, okay? So how you choose the debug version of compiler or release version of compiler. In Visual Studio environment, which is very, very easy. You see this tab. If you choose debug, you are using debug version. Okay, so when you develop a program, you might want to use debug version, which might be run slower, but it's fine for the stage, for the stage that you are creating your program. You are still testing your program, so you are still writing your program. But once your program is done, you should switch to release version, which will compile into a machine code or EXE file. They are more efficient, run faster. So why code release? Normally a company, they develop a program. When the program is ready to deliver to user to use it, they call release version. Okay, release to user. So we call it release version. Okay, so Visual Studio have two compiler. One called debug, which is you can choose debug compiler, or you can choose release compiler. Okay, and you choose debug compiler. There are some very useful tool to trace the correctness of your program. Or put it in other ways, you can stop your program and see the variable at this stage. Okay, and in fact, the debugger feature I only use two features, which is sufficient for me. One is press F10 key. Okay. The other is press Control F10 key. Okay. What is F10? Once you press F10, the program will run to the next line. Just one line at a time. You push F10 once, the program run one line. Okay? And what is Control F10? When you push Control and type in F10, the computer will run until your cursor's location. Let me illustrate, okay? So now I using this program, and I put my cursor here. Okay, I put my cursor here, and I press down Control key on my keyboard, and I press F10. What's F10? F10 is here. Now, my keyboard might be different. Function. I should press function. Okay, so let me do it again. I press the cursor here. So did you see cursor on the screen? Here, it's 9:16. I press my left button on my mouse, and I push down Control and function at F10. So now you see a yellow arrow here. It points to here. It means now the program stopped at this location. Now you can see the value of PI. Okay, when you move your cursor, okay, this is now I circling around this cursor. If I move to a PI, it will show the value of PI, and this small value is the value of PI, and PI is address. So this 0x0000C38, hopefully you can see on the screen, is the address saved into PI. Now you move the cursor to PV. PV also show up a small box which show the value of PV. Okay? Now, since the yellow arrow is here, it means the program stopped temporarily at this location. Now, the variable I has the value of this minus A5899 something. Okay, the variable I has this value, and this in fact a minima integer value, which means I has not been defined value yet. So now I come back to this yellow arrow here, and I push F10 again. In my keyboard, I should type I should press down function key and F10. So the yellow arrow go down one line because I push F10. Now you can see the value of I. This is 自动变数, an auto variable, which is also mean local variable. Okay, the function belong to this, and the value belong to this function. The value become 5 because this statement is being executed. So the variable I become 5. Now, if I keep press F10 again, it go down one more statement. It down this printf. So I can see the screen here. So this is the screen. It print out the result I want. because I just using F10. I just using F10. Okay, I press Control Function F10. I just finish this print statement. So on the screen, I see 1 line of the execution result. But after this yellow arrow, below this statement is not executed again. What I can do is I press F10 again. It go down one more time. So you can see the i's value here, which is tiny I here, and its value is 10. And start PI and start PJ, and they all got value of 10 because they all point to the identical location, which is variable I. Now, when you see the screen, we still have only one printout. Now we come back, we press F10 again. We execute the second printf. Now what you can see on the screen is we have a second line printout. Okay, so you can 9 by 9 to execute your program and check if the variable you change. Okay, so 2, which I only use this 2. In fact, debugger have many other function, but for me, I only use F10 and the Control F10. It's all I need to use, and I write many C program, and this two debugger function is sufficient for me. Okay, so you should know how to do this, because when you do your homework exercise or when you taking the exam, you might find these two functions is very convenient to stop your program. If you do not use these two functions, okay, you do not use these two functions. The other way you can do is using printf. You can printf anywhere you like, and you can check your variables value to see if they are correct value or not, and you can find if the value is not right, then you can find where you make a mistake, where is the bug. Okay, so these two F and a Control F10, F10 and Control F10 is very useful. Okay, now you guys have seen pointer. Okay, now what I want to say is let me finish. Now this program is still hanging here. Okay, it's not complete. It's just in the middle of the program. It's not finished. So you can do is in the upper tab, you find 侦错, and then you choose stop 侦错, or you use Shift F5. Okay. Normally, I just choose stop 侦错, so the program will come back to the initial state. Okay. Now, what I want to say now is that integer variable I, so it's easy. We've seen it many times. We know we have a pointer I, point pi. So we have I variable. This location you can say an integer. Now we have pi, And what is pi? Pi is int star. Okay? And we can define another thing. We call star PPI. Now, what is PPI? What is PPI? Shorthand notation for it is in star. Now, we say PI is what? Is a int variable. PI is a pointer. A pointer. What? Gets stranger again. Is a pointer. Is a pointer to int. And a pointer is what? A pointer is a variable. So a pointer is pointing to a int. Int is a variable. So pointer is also a variable. Can we have a pointer to a pointer? Okay. So PPI is what? I hate. PPI is what? PPI is a pointer to a pointer to. This pointer is point to what? A pointer to a pointer to a pointer to. I'm not drawing. Pointer to. And then we have this again. To int. So it's a pointer to pointer. And this pointer is to an int, which is defined by this guy. PPI. Okay? Now, can we have this? Can we have this? Int star again. What's happening? What's happening? So what is this? PPPI is a pointer to a pointer to a pointer to an integer. Okay? So in the memory space, I is int. Then you have a PI. PI is a pointer to integer. So how you get the value for PI? You take the address of PI, address of I. So if I is 1000, PI is 2000. And after this statement, PI have a value of 1000. Therefore, with this 1000, I can point to variable I. Now, PPI what PPI what's the hell? PPI is equal to ampersand PI. PI is what? PI is a pointer to integer. Now, I take the PI's address and say into PI, into PPI. Now I have PPI here. And it's a pointer to a pointer of integer. So with this statement, now PI have address. We take the PI's address, have 2000 and say into PPI. So PPI have 2000. Now PPI located in 3000. Okay, and we also have a variable called PPPI, and its shorthand notation for its data type is integer star star star. It's a pointer to a pointer to a pointer to an integer. PPPI is a pointer to a pointer to a pointer of integer. Now, what I can do is PPPI is equal to ampersand PPI. What I can do here is take the address of PPI, which is 3000, and save to the PPI. Okay? Now, once I do this, variable I, again, what? Variable I it's not white ball, it's a crazy ball. Variable I is equal to star PI, is equal to star star PPI, is equal to star 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 PPPI. Okay, you cannot understand it. I can rewrite it as I is equal to stupid. I is equal to star PI is equal to star PPI. You take a look at this guy. Is the PPI point to, and then the pointer point to. Okay? So it's star PPPI. So it redirect 3 times. Okay? To what? To variable I. So you see here, getting PPPI getting the value of 3000. So it point to here. Now, once I point to here, I want to take the address to point to the next guy, 2000, point to here. Once I get to 2000, I want to take the address because I use a star operator. I want to use this 1000 to point to here. How many times it point to? 1, 2, 3. So we have 3 star here. So all this guy, this is variable I. This is variable I. And this is variable I. And this is variable I. Okay? So we can say PI is integers pointer. PPI is an integers pointers pointer. PPPI is integers pointers pointers pointer. Okay? Now, let's see this example. It's not difficult to understand. You pay more attention. This is we have variable I. I am going to put in just one line. With variable I, we have a pointer to variable I, to integer. We have pointer to integer, PP, called PPPI, called PPI. We have pointer to pointer of integer. We call it PI. Okay? All these 4 guys are variable. The first one is regular variable, our integer I. And the PI is a pointer, is a variable, is a pointer to integer. And PPI is a variable, is a pointer to integers pointer. And PPPI is also a variable, but it's a pointer to a pointer to a pointer to a integer. Okay? Now, the first step, I take the address and assign to PI. The following step, I take the address of PI. PI is a variable, a pointer, which should have an address for it. So now I take its address and I say into another pointer called PPI. Right? It's perfectly okay. Now, I want to take the address of PPI again. Okay? Once I take the address of PPI, since PPI is a pointer to a pointer of integer, now when I take this pointer, I should say into a 3-time pointer to integer. So PPPI equal to this guy. Now, I set the value of 5. And what I'm going to do is print PI. And print pointer PPI. And then I'm going to print pointer of PPPI and the integer D. So I'm going to print 5 integers. One is I, one is point PI, one is PPI, pointer PPI. Okay? Star PPI. And the star PPPI. what I'm going to do here is I want you guys to understand the concept of pointer's pointer. Okay? So we print 4 integers: first, second, third, and fourth. And first is variable I, second is star pi, the third is star ppi, the last is star ppi. Are we talking about the same thing? In fact, they are all point to the identical location of variable I. So I'm not going to print too many things. Okay? I just change one value or change the last one. PPPI is equal to 10. And we print all this guy. Okay? So they did this. Okay? Once I do this, okay, and then I change the value of variable I, and I change the value of the integer point by the pointer PPPI. Okay? Okay, you can see I is equal to 5. Star pi is equal to 5. Star ppi is equal to 5. Star PPPI is equal to 5. Now, I is equal to 10. Star pi is equal to 10. Star PPI is equal to 10. Star PPPI is equal to 10. Now, student might say, do we need so many levels of pointer? The answer is yes. You want to master the pointer. Sometimes you need to do this, okay? But again, in the redirection of the address, too many times the programmer and the reader of the program will get confused. But you should understand the concept. Pointer is a variable. Its address can be given to another pointer. Okay? So the pointers is possible. As many labels as you like. Okay? What I'm here is just to illustrate the pointers. It's possible to use in C. And you can do this. You can do many things. Okay? You can do many incredible things, I would say. So let's take 10-minute break before we come back for the last hour.
我这一讲是那个跳工作表，可是这边就我有填助理工作表，是每个人都对，
是那个还是要一起交的。
哦，那个一共
我们下个礼拜助教课给他们填。
OK， 好。